Yes. Yes. Okay. Right, we'll start. Today target is, last week we started projectile motion. We started projectile motion, but we have some pending cute questions in vertical motion under gravity. So therefore today intention is completing all the vertical motion under gravity questions, then completing all the projectile motion questions. Right? So then we'll check whether we can do past paper questions from vertical motion under gravity and projectile motion. If we finished all of them, we can start most important section in kinematics, motion graphs. After completing motion graphs in this month, we will start Newton laws, the most important section in mechanics. The most important section in mechanics, Newton laws. Right. Okay, we'll start. I always say that what is important when you're committed to learn, only thing that there is a conversation between you and me only. When you committed to learn and when I start teaching, only thing that there is you and me in between. So your focus should only with my explanation. So don't lose your focus. That's what I always say. And always keep yourself active. Right? Now today we are doing until 1 o'clock. Today almost we are covering questions as much as possible as the target. That's the target. So we'll take break in between, but keep your focus. That is important. That is important. So in vertical motion, what are the questions that we have discussed? Vertical motion, what are the questions to be discussed? Any online student just reply the question that we discussed so far in vertical motion under gravity? Can you please send the question numbers that we discussed so far in vertical motion under gravity? Did we discuss question number 1? 1 discussed, 3 discussed. So now what you do, okay, 3 discussed. Please check with your book. Online people also reply, did we discuss question number 3? Lastly discussed 13. Okay, now we'll start doing question number 13 discussed. We'll start question number 15. We'll start 15. Online student, can someone put the question that we discussed until 15? Send the questions that we discussed until 15. So we'll start doing question number 15. 15. 15. Okay, thank you, Amaya. Thank you. Okay. Start doing 15. Did you do the 15 question number 15? Start doing 15. So you got the answer. So then you keep on doing, if you finish doing vertical motion under gravity questions, you keep on doing projectile motion questions also. Now you are able to do any question. that knowledge that you gained last day. So therefore, don't waste your time. You keep on doing questions. 15. It says that boy on 20-meter high cliff drops a stone. 1 second later, he throws down another stone. Both the stones hit the ground simultaneously. Find the initial velocity of the second stone. Right? There is a high cliff in some kind of mountain, I think. Okay. The story. This is the ground. So you guys don't wait until I explain everything. Now you know what to be done in vertical motion under gravity questions. So you guys keep on trying the question. Right? And this is my high cliff or whatever. So my first stone is red stone. So this is my first stone. First stone. Now they are telling first stone is dropped from rest. First stone is dropped from rest. Initial velocity of first stone is 0 ms minus 1. 0 ms minus 1. And this stone moves under gravitational acceleration 10 ms minus 2. I say that when t equals 0, first stone is dropped. When t equals 0, first stone is dropped. When the moment first stone hits the ground, when the moment first stone hits the ground, time taken by the first stone, I mark it as capital T. Right? When the time is capital T, first stone hits the ground. So that means the time taken by first stone to move from here to here is capital T. They are saying after 1 second later, second stone is not dropped. Second stone is projected down. What is the meaning between dropping and projecting? If you are dropping something down, initial velocity is 0. First stone is dropped, its velocity is 0. Second stone is projected down. That means second stone has an initial velocity. When the time is 1 second, second stone is dropped. Blue color one is my second stone. Then second stone has an initial velocity. I say initial velocity of second stone as u2 something. Then also they are telling the time is 1 second. When t after releasing red color stone, after 1 second later only second stone is releasing. When t equals 0, red color one is released. When t equals 1 second, blue color one is released. I'll ask you one question. In the question, they are telling further, even though both the stones released at 2 different times, both the stones hit the ground at the same time. Both the stones hit the ground at the same instant. I'll ask you, time taken by first stone to hit the ground is capital T. What should be the time taken by second stone to hit the ground? Reply. What should be the time taken by second stone to hit the ground? Reply someone. All of you. It must be capital T minus 1. Time taken by first stone is capital T. Second stone must be T minus 1. Then that's it. What can you say about the displacement of red and blue stone? Same displacement. Both of them have same initial point. Both of them have same final point. Then displacement same. You have an understanding about their times, capital T minus 1. Then what you should do, you want to apply S equals ut plus half at squared. Target is finding this velocity. Very easy. And they have given the S also. They have mentioned the vertical displacement is 20 meters. Then very easy. It's very easy. So then what? This one's time is T minus 1. So I consider first stone, if not red color stone. What can I do? I can apply S equals ut plus half at squared in downward direction, because we apply linear motion equations in the direction of motion. Downward direction. S equals ut plus half at squared. Then displacement is 20 meters. Initial velocity of first stone is 0. Time taken is capital T. 0 into capital T means 0, it's 0. 0 into capital T means 0, it's 0. No need to write down 0 into T. Plus half acceleration acting downwards. I apply linear motion equation also in downward direction. Acceleration also in downward direction. Therefore, into 10. Time taken by the red color stone is capital T. Capital T squared. Then you can find the T here and you want to substitute there. This is very simple question. Very simple question. Then I can find then 20 equals 5. This one is 0. 10 over 2 means 5. 5 capital T squared. When you subject T capital T squared, 20 over 5 means 20 over 5 means 4. You are getting time as capital T as what? Capital T is root 4. If you subject capital T squared equals 4, subject capital T equals root 4. Root 4 means 2 ms 2 seconds. 2 seconds. But my target is finding U2. Now I know capital T is 2 seconds. Then what is the time taken by blue color stone from here to here? Capital T minus 1. That means 2 minus 1. That means 1 second. Time taken by blue color stone is 1 second. Now I can apply for the blue. For the blue stone, if not second stone, in the direction of motion, S equals ut plus half a t squared. Again, same displacement done by blue color stone also 20 meters, same displacement. But I don't know initial velocity of blue color stone, that is u2. My target is finding u2. Time taken by blue color stone is capital T minus 1. T we found as 2. 2 minus 1 means 1 second. Plus half. Acceleration is 10. Time taken is 1 squared. 20 equals u2 plus 1 squared into 10 means 1 squared means 1. 1 into 10 means 10. 10 over 2 means 5. Then your u2 will be 15 ms minus 1. Raise your hands. How many of you got 15 ms minus 1? Any online students got 15 ms minus 1 answer? Yes, there are some. Question number 15 done. Start doing question number 15 done. Then 16. 15 done. 16. 16, 17. Okay. 16, 17, 18. 16, 17, 18. You finished doing 16? 17? 18. Start doing, you do 17 and 18. 16, 17, 18. 16, 17, 18. 16. What they are telling? In 16, from top of 30-meter high cliff, a stone is dropped. At the same instant, another stone is projected vertically upwards from the ground with a speed of 30 ms minus 1. There is a mountain. First stone is dropped from the top of the mountain. Second stone is projecting from the ground. Find the time elapsed when two objects pass each other. Find the distance from the ground at the point where the two objects pass each other. What they are telling? What they are telling in question number 16. If I roughly draw the sketch, okay. Now this is my mountain or whatever, that cliff. Now they are talking about two stones. Both of them are released at the same instant. That means I am releasing first object from the mountain. Also, I am projecting second object from the ground at the same time. I am releasing first object from the mountain and I am projecting second object from the ground at the same time. Right? At the same instant releasing, same instant projecting. Right? So my first object, red color one. Red color object. This object is projected from rest. That means initial velocity is 0. 0 ms minus 1. Okay. When t equals 0, first object is released. At the same time, second object is projected from the ground upwards with a velocity of, what is the velocity? With a velocity of how much? 30 ms minus 1. 30 ms minus 1 when t equals 0. Then what will happen? First object goes down, velocity increases. Second object goes upwards, velocity decreases. But you understand, when you consider their motion, what would happen? At an instant, they will meet each other. This one is going downwards, this one is going upwards. At an instant, they meet each other. We want that instant when they meet each other. So I will tell that when the time is capital T, these two guys meet each other. So if there are two roads, so you are going in this road, another vehicle is coming in other road. When the moment you two guys meet each other, we are talking about that instant. I say that when the time is, because both of them starting their motion at the same time. When the time is t equals 0, both of them start in the motion. When the moment they are meeting, what can you say about the time taken by first object to move from here to the meeting point and time taken for the blue color one to move from here to meeting point? They must be same time. Same time. Right. When the time is capital T, is the meeting point. When the time is capital T, both of them are meeting. From here to here motion, time taken by first object also capital T. From here to here motion, time taken by blue color one also capital T, same time. Same time. Raise your hands up to now, everything is very clear. Raise your hands up to now, everything is very clear. How many of you got this answer for 16 answer? Hands up, how many of you got the answers for 16 answer? No one, only one. So where did you consider it?
I considered they threw it from here.
Throwing from the mountain?
Yeah.
And then can't. Do it. So if you need fan, you can switch on the fan, huh? Raise your hands, how many of you need some time to do the question answer? Raise your hands, how many of you need some time to do the question answer? Yes, I will give you, now time is 9:29, but I can't give that much of time. Today my target is completing all the questions. Just take 4 minutes because, okay, take 4 minutes, take 4 minutes. Actually, they are asking in the question, the distance from the ground to the meeting point. In the question they are asking, distance from the ground to the meeting point. So you should find the simple h. The simple h. What is the height of the cliff? Is it 30 meters? Are you sure? This velocity also 30. Height of the cliff is 30. Both are 30. Both are 30. Right, okay. Then this is also 30. Then I can ask a question. The total height of the cliff 30 meters. I want to find simple h. If I ask you, what is the displacement traveled by red color object? In terms of simple h. Simple h, see, displacement traveled by blue color object. If not, the displacement between meeting point and the ground. Total height of the cliff is 30 meters. What is the displacement traveled by red color object? 30 minus simple h. This is 30. This is simple h. In this gap must be 30 minus simple h. Consider red color motion. Apply s equals ut plus half at square. Consider blue color one and apply s equals ut plus half at square. Two equations simultaneous. You can go to the result. So this gap is 30 minus simple h. I will give some time. Just do it. I think all of you can do it. If you properly understood the concept, this is easy. This is easy. Because I am teaching in that way. So I will give 2-3 minutes. Do it. Target is completing projectile motion questions as well. That's the target. That's the target. So if I consider red color motion, you can apply s equals ut plus half at square. Blue color one s equals ut plus half at square. Can do. Red color one going downwards, downward direction. S equals ut plus half at squared. Get the answer. Got the answer? Then great. And also this week, not this week, after we completed all the questions, past paper questions in vertical motion, projectile motion, we'll have some kind of small test. So we'll have a small exam, online people and physically I can give the paper. Online also, we are doing a paper through a platform called online Moodle. So what will happen? So when you click the paper, there will be a timer. The timer starts running. If the time for the paper is 1 hour, within 1 hour you want to submit the answers. And then I can exactly ensure whether you guys taking 1 hour and you are doing or not. So then we'll keep a test also, we'll evaluate about yourself. So we'll do this. 16 done, 17, 18. 18. Okay. Then SC is 30 minus simple h. 30 minus simple h. Displacement done by red color one, 30 minus simple h. Initial velocity of red color one, 0. 0 into time in 0. Therefore, I'm not putting anything. Half acceleration downwards 10. Time taken by red color one is capital T squared. Capital T squared. If I simplify bit, I can write down 30 minus simple h equals 5 capital T squared. 5 capital T squared. So I mark this as equation 1. This might be useful. Then I consider blue color motion and apply S equals ut plus half at squared upward direction. Blue color one, upward direction, S equals ut plus half a t squared. Blue color motion. So then what is the displacement done by blue color one? A simple h, upwards, simple h. Right? Equals u. Initial velocity of blue color one is 30. Time taken, I told you, time taken by red color one and blue color one, same time. Starting at the same time, meeting at same time. Therefore, both of them have taken same time for their motion. Capital T plus half. I'm applying this equation upward direction, but acceleration acting downwards. Therefore, minus 10. Minus 10 capital T squared. Then I can simplify this. H equals 30 capital T minus 5 capital T squared. How many of you got these two equations answer? You exactly got 30 minus h equals 5t squared and h equals 30 capital T minus 5t squared. Most of you, all of you got that same equation. Great. My target is finding simple h. I think first of all, we have to find capital T, right? We have to find capital T and then only we have to come to simple h. So what will we do? So we'll add equation 1 and 2. So when we add equation 1 and 2, what can we do? 30 minus simple h plus simple h must be equal to 5 capital T squared plus 30 capital T minus 5 capital T squared. What happens? Minus simple h plus simple h cancel out. 5 capital T squared minus 5 capital T squared cancel out. What is remaining here? Left side 30 is remaining, right side 30 capital T remains, then T is 1 second. Then when you substitute the time exactly 30 by 30 means 1 second. 30 by 30 is 1 seconds. We got the timer, but we should find the H. I want to find H. So therefore, I thought of going from equation 2. I know T value. I'm going to substitute in equation 2. T equals 1 second. Then from equation 2, I can write down simple H means 30, time is 1 second, T is 1 second, minus 5, time is what? 1 squared. H will be 30 minus 5 means 25 meters. 25 meters. H is 25 meters. Done. Finished. 15 discussed. 16 discussed. We'll come to question number 18, then we'll go to question number 17. We'll do question number 18, then we'll do question number 17. G means gravitational acceleration. So don't, rather than putting 10, this time instead of 10, put G. How many of you started doing question number 18 answer? Started doing 18. Do 18. Do 18. Now, from this knowledge, I think the number of questions we discussed so far enough. Any vertical motion under gravity question, this knowledge is enough. Just go and if you try the past paper, MCQs and essays also, you understand this knowledge is enough. But we'll do 2-3 more questions and we'll finish the story. Then vertical motion finished, linear motion finished, vectors finished, dimensions finished, units part I didn't do. Measuring instrument part is a practical part. Still I didn't do. I know that. I will do. Don't worry, I will do it. Motion graph section. We'll complete kinematics. We'll keep on doing. Right, 18. One stone was projected vertically upwards at u velocity. After t time later, another stone projected vertically downwards at the same velocity. Show that the two stones meet each other this much time after first stone is projected and find their velocities as well. Find their velocities as well. Okay. Do it. I'll give some time. Do it. Question number 18. So these are the difficult questions in vertical motion under gravity. If you understand this means you are okay with theory. That's it. If you have the interest, remember any question in your exams can do. Please try to think the way that I think. That is the important thing. I will guide you. Question number 18 says that one stone was projected vertically upwards with velocity u. So I consider here my first stone as blue color one. When the time is t equals 0, first stone is blue now. Not normally I take my first stone as red, but this time I take my first stone is blue. I am projecting blue stone vertically upwards with velocity u. Initial velocity is u. When t equals 0, blue stone is projected upwards with a velocity of u. And they are saying after simple t time later, second stone is projected vertically upwards. Okay, better I draw a diagram. Better I draw a diagram again. It's okay. I will draw a diagram. Question number 18. Question number 18. Is my ground. So first stone I consider as my red color stone. Projected with initial velocity u. Okay. When the time is t equals 0. Then what happens? This one goes upwards, reaches maximum height. At the maximum velocity is 0 and comes downwards. Velocity increases. You know what is the type of motion. They are telling after simple t time later, second stone is released. My second stone is blue color one with the same velocity. Are they telling second stone also released with the same velocity? After simple t time later, when the stone was projected vertically upwards, same velocity u, same velocity u. But the time is now, when the time is simple t, projected upwards, same velocity u. So this one also goes upwards. Goes upwards. What they are saying in the question, they are telling, show that two stones meet each other. I will ask you one question. When t equals 0 second, first stone is projected upwards with velocity u. Now this one is going upwards, upwards. Sometimes now they can reach at the maximum height when we release the second one. Because second one is releasing after some time later. We don't know when the moment we are releasing. Second one, where is the exact location of first one? We don't know. First one is going upwards. When t equals 0, first one is projected. First one is going upwards. Going upward. When the time is simple t, second one is projecting. Same velocity. And now both of them are going upwards. Maybe sometimes first one reach the maximum height and maybe first one is coming back when second one is going upward. When a moment, what will happen? They meet each other. And definitely look here, when the moment they meet each other. When the moment they meet each other, understand, first one might have reached maximum and he has come down somewhat. Am I correct? Second one, when second one is going upward, but first one reached maximum height and coming back down, then only they can meet each other. Why second one is throwing lately? Then careful listen. So you also listen. When the moment I say capital T, see, when the moment capital T, I assume both of them are meeting again, right? So then where is my second one? Second one is also here. When the moment capital T, both of them are moving. Sorry, both of them are meeting. When t equals 0, first one is released with same velocity u. This one is going on a path like this, reaches maximum height and coming downwards. As it coming downwards only, he is meeting the second one. but second one is still going upwards. Second one still didn't reach the maximum height even. That's the way, right? Why? Because you are throwing this one bit later. Am I correct? Am I correct? Then I say that when the time is capital T, both of them meet each other. I will ask you one question. In terms of capital T, simple T, tell me what is the time taken by red color one when the moment both of them meet each other? Capital T. Because when T equals 0, first one is released. When the time is capital T, they are meeting. Time taken by red color one is capital T. When the moment both of them meet each other, what is the time taken by blue color one? Reply everyone. In terms of capital T and simple T, tell me when the moment blue color one meets red color one, what is the time taken by blue color one? Reply someone, chat box. What is the time taken by blue color one? Any replies? I am expecting an answer from all of you. Which one is larger? Simple T is larger or capital T is larger? For an example, when T equals 0, red color one is projected. When T equals 2 seconds, blue color one is projected. When the moment they are meeting, time must be greater than 2 seconds. When the time is 5 seconds, both of them are meeting. So therefore, capital T must be larger than simple T. We understood time taken by red color one is capital T time. Time taken by blue color one must be capital T minus simple T. Hands up, genuinely understood the time taken by red color one is capital T and time taken by blue color one is capital T minus simple T. Hands up. So this one takes capital T minus simple T time. Capital T minus simple T time. Am I clear what I'm explaining? Are you very clear? Hands up, okay. Now there are some online hands up. Hands up if you understand. The only difficult thing is understanding time taken by red color one and blue color one. Time taken by red color one is T, capital T, blue color one is capital T minus simple T. If you understand that idea, hands up. Especially online people, raise your hands genuinely if you understand that idea. Okay, then I hope all of you understand. Now hereafter same. Hereafter same thing you want to do it. You should get that thing. You want to find capital T only. Your target is finding capital T. They're asking, show that two stones meet each other this much time after the first stone is projected. So you want to find capital T. Found the answer? You got the answer? You want to find capital T. You want to find, you should show that capital T equals. You should show that capital T equals what is given in the bracket? Simple T over 2 plus U over G. You want to show that capital T is T over 2 plus U over G. That is your target. You can consider red color motion and you can apply S equals UT plus half AT squared. You can consider blue color motion, apply S equals UT plus half AT squared. Get it? What can you say about the displacement done by red and blue? Same displacement. Initial point is here. When the moment they meet, final point is here. Same displacement. Blue color one, initial point is here. Final point is here. Same displacement, same displacement. What can I do? Red color one. I will give some time. I will give some time because we are finishing vertical motion questions. 9:52. I will give 4 minutes. Now, G means, in that question, G means gravitational acceleration. Now, normally, when you are substituting for S equals UT plus half AT squared, A means gravitational acceleration. Normally, you substitute 10, right? Rather than substituting 10, substitute simple G. Don't substitute 10. Only substitute simple G. Simple G means gravitational acceleration. I will give 4 minutes. Try to get it. Try to get it. For the red color one, I can apply SC equals UT plus half AT squared in the initial direction of motion upwards. SC equals UT plus half AT squared. I consider displacement is simple H. Displacement simple H. Simple H. Initial velocity U. Time taken by red color one is capital T. I want to find capital T plus half linear motion equation applied in upward direction, but gravitational acceleration is in downward direction. Therefore, minus, normally we substitute minus 10, we'll substitute minus G. Time taken, capital T, squared. So then we can write down simple H equals, okay, U capital T minus G by 2 capital T squared. So this will be equation 1. When I consider blue color one, if I consider blue color one is also going in upward direction. S equals UT plus half AT squared upwards. Same displacement, simple H. Initial velocity, same initial velocity U. But blue color one takes capital T minus simple T time. Plus half. Acceleration is same as minus G. Blue color one takes capital T minus, now we want to expand the brackets, I think. Capital T minus simple T. There is a big simplification here, I think. Okay. Anyways, okay. Then I can write down simple H means U capital T minus simple T minus G over 2 capital T minus simple T squared. I put this as equation 2. Raise your hands. How many of you obtained these two equations answer? Exactly same these two equations. Didn't you get it? Why? Can't? It's wrong, right? No. If you put any plus G or something, then it's a problem. Then you should not get the answer. All people keep on doing what you want to find capital T, so then you can subtract.
And minus UT, minus dt square and dt square. And after that, I got the lines like this. Then I got this here. Then I divided everything by G. Then this G will cancel, and here over G like this. After that, I took this T. This will cancel and this will cancel. So then T over 2 minus U over G.
And that's why.
I should have substituted minus.
From the beginning, do it. You're good. You know, I don't say this. Sometimes some people become pride when we say something. But I will tell that Afla didn't have this potential in the beginning. Okay, you can go for a long path. I don't know. I'm okay. Even you don't come to my class also, I'm okay. But wherever you go, polish your skill. I can say only that. You can go for a long path, polish your skill and go wherever you want. But my class is, I don't say you to come to my class, but if you come to my class, better. I can guarantee, I can money, I can guarantee some ways. It's up to you. Okay, do it. Okay. Okay, now what can I do? Now I'm subtracting equation 2 minus equation 1. I'm subtracting equation 2 minus equation 1, but it's a long, we have to do a long, here this theory is this much. Here after finding t, some kind of simplification, right? If you understood the question and if you wrote these two equations, then you are in good level. But hereafter simplification is there, it takes time, and it's a big simplification. You want to expand the brackets also. We'll do it. Equation 2 minus 1. Equation, but you understood, right? So every question we want to apply same idea. If you draw the right sketch, getting the answer is not a big thing. If I subtract equation 2 minus 1, h minus h cancel out. You know that. H minus h cancel out. Then I expand the brackets. If I expand the bracket, u capital T minus u simple t. I hope you guys understand. U capital T minus u simple t minus g over 2. I expand the bracket. Capital T minus simple t whole square, I expand at first. Right? Capital T minus simple t whole square bracket, I expand at first. All level knowledge, t squared minus 2 capital T simple t plus simple t squared minus equation 2 minus equation 1 minus, now equation 1 minus this one, this entire thing, u capital T minus g over 2 minus g over 2 capital T squared. Simplified further. H minus simple h 0. Hands up who need some time to get the answer. Hands up who need some time to get the answer. We do it. Hands up who got the answer already. Already got the answer, anyone? Any online people? Already got the answer. It's very beautiful question. Equals u capital T minus u simple t. Now expand again. Multiply all these terms by minus g over 2. Minus g over 2. Minus g over 2. Minus g over 2. Expand it. So then minus g over 2 capital T squared. Likewise do it. Likewise do it. Likewise do it. So then minus g over 2 minus 2t. Minus g over 2 minus 2tt means plus ni. Minus into minus plus g over 2 plus g over 2 into 2 capital T simple t. Okay. Then this one, if you expand minus g over 2, if you multiply minus g over 2 with simple t squared, minus g over 2 simple t squared. Expansion, oral knowledge. And now you want to expand this bracket also with minus. Minus into ut, minus ut. Minus into minus g over 2 t square means minus minus plus G over 2 T square minus UT minus into minus plus G over 2 capital T squared. Capital T squared. Now you just check that any terms that you can cut. Are there terms that we can cut? Yes, there are. Look this UT, U capital T, and in here there is minus U capital T. This is plus U capital T. This is minus U capital T. What you can do, you can cut them. Likewise, are there any terms that we can cut? Look here. Here, minus G over 2 capital T. Here, plus, sorry, minus G over 2 capital T squared. Here, plus G over 2 capital T squared. We can cut. We can cut. We can cut. We are cutting. What else? Are there anything else? It seems like no, right? Seems like no. Then what can we do? We can write down 0 equals minus UT minus UT. These 2 and these 2 cancel out, plus G capital T simple T. Don't worry, in your A-level exam, they don't give this type of questions. A-level exam, they don't give this type of questions, but practice solving these type of questions. That's good. Minus UT is available here. Then this one is available. Then this one is available here. Minus G over 2 capital T squared. That's it. I want to substitute capital T. I thought of moving minus UT to the left. I thought of moving minus GT squared to the left. Then what I am getting? UT plus G over 2 T squared must be equal to G capital T simple T. See? G capital T simple T. Now look at how many terms are there. There are 3 terms. First term, second term, and the last term, third one. When you consider all 3 terms, simple T is common in all 3 terms. What can I do? I can divide all the terms by simple T. I can divide all the terms by simple T. Simple T. Divide by simple T. Divide by simple T. Then simple T cancel out. Simple T cancel out. Simple T cancel out. Finally, I am ending with U plus G over 2 simple T must be equal to G capital T. I want to substitute capital T. I want to find capital T. I want to find capital T. Then what can I do? Dividing again all the terms by simple G. Dividing all the terms by simple G. Simple G. Simple G. Finally, I am getting U over G. U over G plus this simple G cancel out. What is remaining? T by 2. T by 2. This simple G cancel out. Capital T. What I want to show? I want to show capital T equals T over 2 plus U over G. T over 2 plus U over G. Finally, you can write down capital T means T over 2 plus U over G. That's the answer. Genuinely hands up. Up to now, everything is very clear. Hands up, everything is very clear. Need a break? Need a break? Better we do now. How many questions we discussed so far? How many? How many discussed? Do you have marked everything? You have marked everything? All the questions that we discussed in the vertical motion, did you mark? We completed first one also. These things note. So then how many are there? Only few are there. 16 done also. 18 also done. We'll do 2 more questions and we'll go to projectile. What do you want? What do you want? 17. Shall I do 17? We'll do 17. 17 is very different question. 17. So we'll do 17 and we'll discuss. We want to finish now. Story finished. 6, 7 didn't we discuss? Why question number 6 and 7 didn't we discuss? We discussed 6 and 7. Yes. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 we discussed. Amaya has put we discussed 6 and 7 also. 6 and 7 discussed, 1 discussed. We didn't discuss 2. 2 is not discussed, 1 discussed. 1 discussed. 6, 7 also discussed. Is to discussed. 12 didn't discuss because 12, this derivation is wrong, I think, question number 12. That derivation is wrong. 16 discussed, 18 done, 17. Okay, 17. Last 2 child. We didn't discuss 14. Okay, last 3. Okay, we finish. We'll discuss question number 17. We'll discuss 14 and decide with your idea whether to go to discuss 19 and 20. If you want to discuss, we'll discuss it, but story is finished. But 17 is very good question. I think most of you could not do 17 question. I think most of you could not do it. I know that. 7 is a good question. We'll discuss that. We'll discuss. Then we'll take a break if you want. We'll take a break and then we can start doing projectile motion question and remaining theory. Still, there are some theory to be covered in projectile motion. Then I will teach you that. Now we are talking about no air resistance situation. I will teach you what will happen when there is air resistance when there is a motion upwards. I will teach you that later. Okay. 17. 17. 17. I will give you the idea. Without the idea, sometimes you did write 70. Still writing this? Anyone writing this answer? Anyone writing this answer? All of you finished writing, right? 17, no, not like what you think. Did you consider that balloon's motion? You didn't consider that balloon's motion, right? Only you consider that rock's motion. Then it's wrong. Then it's wrong. That's why. Now, parallelly, now you know what's happening. In that question number 17, parallelly, rock. Now, the person is inside the balloon. The person is throwing a rock. That rock is also moving. Balloon also moving. I will explain. Don't worry. I will explain. And I say that if you have any term test plans, please send your term test plans and everything. In your school, if they have announced your first term, tell me. And when I ask what kind of feedback, please don't hesitate to give feedback. Feedback means what I don't want any pluses. Now it's been, I think, 7-8 years. I heard lots of pluses and not only to satisfy myself. So, but what is the drawback that you see in online class, especially? Then sometimes some people, there might be some connection issues. If not, but sometimes tutors won't post in the right time. Sometimes even though I post in the right time, you don't receive the tutors right time. So likewise, the drawbacks that you see, please send. Sometimes when you receive the tutors, sometimes what will happen is tutors are damaged. So then, sir, you are not giving enough time to do the questions, to practice ourselves first. So those issues, if you have, tell me. Then we'll talk. It's a very small class. We can discuss and we can do this beautifully. Okay. Oh. Seventeen. Balloon is moving vertically upwards with uniform velocity 15 ms minus 1. Remember, now we are talking about vertical motion under gravity. That means always we know that what happens when object is going upwards under vertical motion under gravity, we consider velocity is gradually decreasing, reaches zero velocity, then goes downward, velocity increasing. But now they are telling in the question, balloon is moving vertically upwards under uniform velocity. That means balloon is moving in a constant velocity motion. What is the only equation we apply for a constant velocity motion? S equals ut. Remember, I taught you projectile motion also. I taught you if it is a constant velocity motion, always apply S equals ut for the balloon. Okay. When t equals 0, a stone is dropped from it. When t equals 0, a stone is dropped from it. Find the displacement between stone and the balloon after 4 seconds. After 4 seconds. I will draw the balloon and stone. Okay. Right. My balloon. So better you draw a big diagram because so keep some space in up. So this is my balloon. This is my balloon. Okay. Balloon, this is the level. When t equals 0, they are saying, when t equals 0, balloon is moving upwards with a velocity, how much? 15 ms minus 1. 15 ms minus 1. So you also listen, this is important. When you consider motion of the balloon, that is constant velocity motion, only equation you should apply for the balloon is S equals ut. S equals ut. They are saying a stone is dropped from the balloon. I will ask you one question. I know I want all of you to answer. Online and physical, I want all of you to answer. Now there is a person inside the balloon. He is dropping a stone. Right? He puts the hand out from the balloon and now he is dropping a stone. Let's think that now I am in the balloon. Now I am in the balloon. I am in the balloon. And now balloon is going upwards with velocity 15 ms minus 1. And I put my hand out and I am dropping a stone. My first question is, everyone reply, what is the initial velocity of the stone? What is the initial velocity of the stone? Reply everyone. I want everyone's reply. Now I am in a balloon. That balloon is going upwards. So I put my hand and I am dropping a stone. What is the initial velocity of the stone? Reply everyone. All of you answering, initial velocity is 0. That is wrong. That is wrong. That is wrong. All of you are answering, now I'm dropping. They are saying I am dropping a stone. All of you are telling initial velocity of the stone is 0, but that's wrong. Remember, when you are in now you are in a bus. Let's say a bus is moving with 50 ms minus velocity forward direction. If I ask you, what is the velocity of you in the bus? You can't tell. Just because you are sitting in the bus, you can't tell your velocity is 0. Whatever the velocity obtained by the bus, your velocity also same velocity. If you are moving in a bus, if bus is moving with 50 ms minus 1, your velocity also 50 ms minus 1. And now balloon is going upwards with 15 ms minus 1 velocity. Do you think Do you think when you drop the stone, do you think will it go down actually? You can try and you can see. When you drop a stone, do you think that stone goes down? No. That stone goes up. Stone goes up. That's actually what's happening. The best example is now when you are going in a bus. Let's say your bus is going so fast. Now when you throw a very light something, let's just say polythene bag or something. When you throw a polythene bag like this, when you drop a polythene bag like this, will the polythene bag goes back? Polythene bag initially goes front and going back. That's what happening actually. So red color pen, write down. Red color pen, important, write down, important. Write down. When the stone is in the balloon. When the stone is in the balloon, comma, stone obtains velocity of the balloon. Stone obtains velocity of the balloon. Stone obtains velocity of the balloon. Therefore, initial velocity of the stone is 15 ms minus 1 upward direction. Therefore, initial velocity of the stone is 15 ms minus 1 in upward direction. Upward direction. It's a good question. And now you understood the idea. Now you know, I will draw my stone in red color one. My stone is in red. The first mistake that you guys made is you guys thinking, now we are dropping the stone. Therefore, stone's velocity is 0. Stone is going down. That's wrong. Now you understood. Stone is also going upwards at the velocity of 15. But stone is moving in a vertical motion under gravity. Remember, balloon is moving under constant velocity, but stone is moving in a vertical motion under gravity. Okay. They are asking, simple A, they are asking, what they are asking? When t equals 0, stone drop from it, find the displacement between stone and balloon after 4 seconds. First of all, what you do, when t equals 0, stone is released, initial velocity of the stone is upwards 15 ms minus 1. I advise, find the displacement done by the stone after 4 seconds. When the time is 4 seconds, find the displacement done by the stone. We know initial velocity of the stone 15, acceleration, gravitational acceleration, time taken is 4 seconds. You can find the displacement. What is the best equation? S equals ut plus half at squared, and quickly find the displacement done by the stone after 4 seconds. Can do it for the stone. For the stone. From t equals 0 to t equals 4 seconds. For the stone. I apply, initially stone is going in upward direction. Upward direction I can apply S equals ut plus half at squared. Upward, S equals ut plus half at squared. I want to find the displacement done by the stone. I put the displacement of the stone is S1 something. S1. Initial velocity of the stone is 15. Time taken is 4 seconds plus half. Acceleration downwards minus 10. I don't explain now why. Time is 4 seconds, 4 squared. 15 into 4 means 60 minus 10 over 2 means 5. 5 into 4 squared means 16. Then I am getting S1 as minus 16 into 5 means 80. 16 into 5 means 80. I am getting my answer as minus 20 meters. You know why we are getting minus 20. You know why we are getting minus 20. But do you think, is this the answer for simple A? Hands up who says this is the answer for simple A? Is this the answer for simple A? No, right? Now we noticed when the time is t equals 4 seconds, displacement of the stone is minus 20 meter means what is the meaning of minus 20? Stone is, when the time is 4 seconds, stone is below this level. Stone is below 20 meter from this level. If I draw the path, very carefully listen. When the time is 4 seconds, when the time is 4 seconds, your stone is, oh God, I need some space here after me. Oh, I want to draw it again. Oh, shit. Because now when the time is 4 seconds, it's coming here. Now again, they ask me the time is what? 10 seconds, then I want to draw something here. Okay, it's okay, it's okay. I will draw somewhere here. Okay, right. When the time is 4 seconds, this is the time equals 4 seconds, this level. Okay, this level, please mark the levels properly, yeah? This is when t equals 4 seconds. What is this gap? This gap is how much? Initially stone is here, finally stone is here. Then displacement is minus 20. This is 20. This gap is 20 meters. But they're asking when t equals 0, both of them are moving upwards 15, 15. When t equals 4 seconds, stone is here, but this balloon is also moving upwards. Balloon is going under constant velocity. Shall we find displacement done by the balloon within 4 seconds? Balloon is moving under constant velocity motion. When t equals 0, balloon is here. When the time is 4 seconds, I say balloon is somewhere here. When the time is 4 seconds, my balloon is somewhere here. When t equals 4 seconds, my balloon is somewhere here. When t equals 4 seconds. What is the equation we want to apply? For the balloon? For the balloon, what is the equation? S equals ut equation, because balloon is moving under constant velocity. For the balloon, I'm applying S equals ut upwards. S equals ut upwards. S equals ut upwards. So displacement done by the balloon, I mark it as H1. Displacement done by the balloon, I mark it as H1. Velocity of the balloon is how much? 15. Time is 4 seconds. Velocity is 15. Time is 4 seconds. Then displacement done by the balloon within 4 seconds is 60 meter. H1 is 60 meter. H1 60 meter. H1 60 meter. Then initially balloon is here, this level. When the time is 4 seconds, balloon is in this level. Then what is this height? This height is 60 meter. 60 meter. Then what is the answer? In simple, they are asking when the time is 4 seconds, gap between balloon and ball, stone. When the time is 4 seconds, what is the gap between balloon and stone? 80. Here is the balloon when t equals 4 seconds. Here is the ball, here is the stone when t equals 4 seconds. Gap between these two, this gap is 20, this gap is 60, 60 plus 20 is 80. Therefore, gap is how much? Gap at t equals 4 seconds is how much? 60 plus 20, answer is 80 meters. Do you understand? I will give some time. The last one, do it by yourself. Simple B, total time after, no, what they are asking, when the time is 4 seconds, oh God, another stone. It's a mess, nee? This is a good question. That's why now I always say that, please practice to what I'm saying. Now, there is a trend now I noticed most of students want to cover the syllabus as soon as possible. Right, mark my word, covering the syllabus is important, mandatory. But always don't try to cover your syllabus without doing enough questions. Always give priority to do questions. There is no use, even you cover your syllabus before 1 year prior to your exam, if you are not thorough with the question. If you didn't do enough number of questions, remember, in your exam paper, even though you learn the theory, you can remember the theory, you are not able to do that question by using that theory. So therefore, please go for the places where they do more questions. It's completely all right. They take time to cover the syllabus. Okay, if even they don't cover the syllabus before 5 6 months, it's okay. If they are covering somehow by doing many questions, give priority for that. Right, my plan is for this batch covering the syllabus at least 3.5 months before. At least that is the plan. That is the plan. Can do it. We are really forward than other 26 batch people. That's the plan. That's why I'm doing. But I'm not reducing the questions. Normally, class duration is day by day getting high now. 3 hour, 3.5 an hour, 4 hour. Normally, why we are doing questions. So therefore, please adopt to that. Don't tell that now 4 hour classes online people I can't stay. Those are now fake. So in the beginning of this online classes, what happened? Students, they said that really can't focus online, want to look at the screen for more than 2 3 hours. We can't focus. 2019, it was obvious because adopting suddenly is not easier. But now, because those days, what your parents or what your grandfather, grandmother told when we asked them to use a touch phone, they say no touch phone. I don't know how to on. I don't know how to off. Now, who are using smartphones? Only grandfather, grandmother, father, mother. So therefore, in the beginning, adopting is difficult, obvious. Now, 2024, 25, 26. So therefore, now it's you can focus, even you are joining classes through online, can focus. If you are not interested only, you can't focus. If you're really committed to that 3 4 5 hours, you get tired. There is no doubt you get tired. Even you come physical class also, you get tired. That's obvious. But you can focus if you are interested. If you are not interested, if your mind is going everywhere, then there's a problem. Now say that now your father is doing something, your mother is preparing a meal, and you are focusing, and suddenly what your mother is preparing, okay, let's go and check what today is curry, what today is na rice. Let's see, there is a fridge, and yesterday father bought some yogurt. We'll go and we'll have the yogurt and come. Then if your mind is going everywhere, it's a problem of yours. Okay, that's what I'm saying. That's what I'm saying. Okay. Time is 10:30. We start at 9:10. We start at 9:10. Time is 10:30. Need a break. Shall we take a break and come? What shall we do? Online people, hands up. Shall we take a break and come? Hands up. We'll break now. We'll take a break and we'll complete this question and one or two, and we'll go to projectile motion. Shall we take a break and come? Hands up. Break. We'll take a small break and come. A small break, only one. What about you, bro? Small break and come. Then how long you need? Reply. Online people. How long you need break? Put in the chat box how long you guys need a break. How long? Reply. Reply, will you? So we'll take a 15-minute break. Time is 10:33, 10:43, 10:48, 10:50. Come at 10:50. Come at 10:50, then 11:50, 12:50, 2 hours we'll do continuously. Come at 10:50. Take your break, eat something, drink something and come. Yes, right. We'll continue again. We'll continue again. Simple B. Okay, we'll finish doing simple B and no, then we discussed, I think, until 18, right? 14, we'll see. If not, directly we'll go to projectile motion questions. Now, I hope that you guys know what to be done in this. I think this is the level maximum. The difficult question they can ask is the previous question. That is the difficult question they can ask from vertical motion under gravity. That is the idea. Okay. Then simple B, when t equals 4 seconds, another stone is dropped from balloon. Find the displacement between the two stones after 6 seconds from the projectile of second stone. So we'll see. I will give this as an homework. Simple B, I am giving as an homework, and please send the working. I don't mind you are getting right answer or wrong answer. I don't mind that. But what I mind your efforts. If I see you are working, this guy has done something. This guy has thought something. Right? Simple B as a homework. So then we have to do question number 14. Is it difficult? Is it difficult 14? Very easy. Very easy. 14 also easy. So therefore, we'll go to projectile motion and we'll come back if you want. If you request to do some questions, there are only 2-3 pending. No need to do it. We'll go to projectile motion. We'll come back. So we'll go to projectile motion. Projectile motion. Last day, please send me someone quickly the questions that we discussed in projectile motion. Questions we discussed in projectile motion. Please send me. Send someone questions we discussed in projectile motion quickly. Quickly. Questions that we discussed in projectile motion. Send me quickly. I can remember we discussed second one. And what else? Second and 12th. Only those two questions. Huh? Online, can someone reply? We only discussed 2 and 12. That means we have discussed lots of questions. Okay, start doing question number 11. Start doing 11. Start doing 11 and 11. If not different, start doing 18. Didn't we discuss 18? Okay, 11. Start doing 11, 18, 19. Question number 11, 18, 19. Question number 11, 18, 19. I will erase this also. 11, 18, 19. The time is 10:53. Until 1 o'clock, I keep on doing question. 11, then 18. Object projected with the speed of 10 root 2 at an angle of 45 degree with the horizontal. Find the velocity after 10 seconds. Find the velocity after 10 seconds. Question number 11. Projectile motion. Projection velocity, how much? 100. 100. Root 2. ms minus 1, angle 45. 100 root 2. This angle is 45. Projectile motion. This is the point belongs to maximum height. What we know at the maximum height, vertical velocity component is 0. I'll ask you one question. Many times we know vertical velocity component at the maximum height 0. What is the horizontal velocity component at the maximum height? I explained lastly. What is the horizontal velocity component at the maximum height? I told you in a projectile motion, any point has same horizontal velocity component. What is the initial horizontal velocity component? 100 root 2 cos 45. So any point on the projectile motion, horizontal velocity component must be 100 root 2 cos 45. Keep them in your mind, but not related to this question. What they're asking? Find the velocity after 10 seconds. Now, I don't know when the time is when t equals 0, object is projected. I don't know when the time is 10 seconds. I don't know where is my object in the path, parabolic path. When time is 10 seconds, my object can be somewhere here or somewhere here. Actually, I don't know. I am assuming, we can assume, right? We can assume, I am thinking when the time is 10 seconds, my object will be somewhere here. Maybe right or wrong, it's okay. When the time is 10 seconds, my object will be somewhere here. They are asking us to find the velocity when object is at here. When the time is 10 seconds, what is the horizontal velocity component of the object? I told you. What is the horizontal velocity component of the object? Same as 100 root 2 cos 45. Am I correct? Horizontal velocity component, I put it as V capital H. So we know horizontal velocity component remains constant throughout the motion. Whatever the horizontal velocity component initially, 100 to 2 cos 45 is same for everywhere. So when the time is 10 seconds, horizontal velocity component will be 100 root 2 cos 45. The value of cos 45 is 1 over root 2. Root 2 cancel out. Horizontal velocity component will be 100 ms minus 1 when the time is 10 seconds. Okay. Hands up who got this answer, but they are asking velocity at 10 seconds. Now this is the horizontal velocity component at 10 seconds. I want to find the corresponding vertical velocity component also. Then you should consider the resultant of these two. Am I correct? At 10 seconds, horizontal velocity component is 100 ms minus 1 and try to find the vertical velocity component at 10 seconds. The resultant of horizontal component and vertical component will be the answer that you are seeking. So then if you want to find the vertical velocity, you want to consider equivalent vertical motion. Right? I am considering equivalent vertical motion. I see from point A to this point is point B. Equivalent vertical motion from point A to point B. Equivalent, you got the answer? Equivalent vertical motion. From where to where? From t equals 0 to t equals 10 seconds. If not from A to point B. If I draw the equivalent vertical motion sketch, initially, what is the initial vertical velocity? Initial vertical velocity component will be 100 root 2 sine 45. Initial vertical velocity component will be 100 root 2 sine 45. Yeah? So then Okay. So what is 100 root 2 sine 45 somewhere else if I simplify it? If I simplify it, 100 root 2 sine 45. Initial vertical velocity component. 100 root 2 sine 45. I simplified somewhere. Sine 45 means again, you know, it's 1 over root 2. Ni? That means 100 root 2 sine 45 means again 1 over root 2. Again, I am getting it same as 100 ms minus 1. Initial vertical velocity component is also 100. 100. My target vertical velocity at 10 seconds. I say in the equivalent vertical motion at 10 seconds. Object will be somewhere here. My target is to find this VV, vertical velocity component at 10 seconds. I want to find VV. Time is 10 seconds. Acceleration, gravitational acceleration. Acceleration, gravitational acceleration. What is the best linear motion equation for the equivalent vertical motion? V squared equals, sorry, V equals U plus 80. V equals U plus 80. Upward direction I can apply. Upward direction I can apply. V equals U plus 80. Hands up, how many of you applied V equals U plus 80? Hands up. From A to B, equivalent vertical motion? Yes. Upward direction, V equals U plus 80. Final vertical velocity is VV. I want to find that only. Initial velocity is 100. Acceleration minus 10. You know why? Time taken is 10 seconds. I am ending with vertical velocity component at 10 seconds is 0 ms minus 1. I am ending vertical velocity component 10 seconds is 0 ms minus 1. What is the problem? What is the conclusion that you obtain from this result? Actually, I don't know now. In the beginning of the question, I told you that now this object is moving in a parabolic path. I told you, I don't know where will be the object when the time is 10 seconds. We can't tell anything. So I'm thinking, right, object might be somewhere here. But where is the object exactly? When the time is 10 seconds, object exactly at the maximum height. Why? At 10 seconds, object is at the maximum height. We know in projectile motion, vertical velocity component becomes 0 only when the object is at the maximum height. Then we understood actually at 10 seconds. Actually at 10 seconds, in the projectile motion, object is at the maximum height. Vertical velocity component is 0. Horizontal velocity component, you guys found that same as 100. I will ask you, now already we learned vectors. We know vectors. What is the resultant velocity at 10 seconds? Reply everyone. Everyone reply. It's okay, right or wrong? At 10-second time period, I found vertical velocity component is 0. Horizontal velocity component is 100. I'm asking, what is the resultant velocity of the object at 10 seconds? Reply. Reply. What's your answer? 100, right? Because if there is no vertical velocity, if there is only horizontal velocity, result is 100. Therefore, answer for simple A is 100 ms minus 1. That is the answer. Then do simple B, same thing. Did you do simple B also? So therefore, answer is velocity is 100 ms minus 1 to the right side direction. Velocity is how much? 100. ms minus 1. If you want, you can put the direction also, right side direction. No, can't. Again, you want to start from the beginning. Simple B. Hands up who started doing simple B, hands up. Simple B started. Anyone? Simple B, now velocity after, now we can assume. Again, they are asking us to find the velocity after 15 seconds. When the time is 10 seconds, object is at the maximum height means when the time is 15 seconds, we know this object must be somewhere here, right? When the time is 15 seconds, we know object must be somewhere here or here, somewhere here. Now we have the understanding. Okay. Now, okay, simple B. Simple B. I'll erase these things, huh? Simple B now. Simple B. When the time is 15 seconds, what is the horizontal velocity? Same. I told you throughout the projectile motion, horizontal velocity component remains same. Even time is 15 seconds. Even time is 15 seconds. Your horizontal velocity component same as 100. Am I correct? When the time is 15 seconds, horizontal velocity component, your VH will be same as 100. Same as 100. So therefore, VH 100. But vertical velocity component you want to find. When the time is 15 seconds, you want to find the vertical velocity component. Same thing, you want to apply V equals U plus 18, you want to find it. Horizontal velocity component at 15 seconds, same as 100 ms minus 1. So I consider equivalent vertical motion from here to here. If I draw the equivalent vertical motion from here to here, initial vertical velocity component same as 100. 100 root 2 sine 45 means 100. Finally, object is here. Time taken is 15 seconds, t 15 seconds. Acceleration, gravitational acceleration downwards 10 ms minus 2. What you should find, you want to find the final velocity. You want to find the final velocity. Final velocity, final vertical velocity at 15 seconds, VV. So again, you want to apply V equals U plus 80 in upward direction. Because we always apply in the upward direction. Upward direction. V equals U plus 80. I want to find the velocity, final vertical velocity. Final vertical velocity when the time is 15. Initial velocity in upward direction 100 plus gravitational acceleration minus 10. Now time is 15 seconds. I'm ending with 100 minus 150 minus 50 ms minus 1. Why I am getting minus 50? Because I applied the equation upward direction, but final velocity is in downward direction. Is it true? It's true. Final velocity is in downward direction. Okay. Very clear. I found at 15 second, horizontal velocity is 100, vertical velocity is 50. But they're asking what is the velocity at 15 seconds? You should find the resultant of these two. I taught you when I was teaching vectors how to find the resultant when there are two components perpendicular to each other. I taught you that idea also. Then horizontal velocity component is 100 ms minus 1. vertical velocity component downwards, 50 m is minus 1. These are perpendicular to each other, horizontal and vertical. The resultant velocity, you know that resultant velocity will be in this direction. We'll mark it as capital V. Target is finding capital V. How do you find capital V? How do you find capital V? How do you find? So you can remember that. You can remember if there are two components. Let's say now, let's say theory, vectors theory. There are two components. Let's say V1 horizontal component and V2 vertical component, perpendicular to each other. If the resultant is, let's say, VR, I told you VR means you can remember root V1 squared plus V2 squared. This is a theory that we learned in vectors. I hope you guys can remember these things. If you can't remember, refer it. Take your vector note right now and refer it. If I follow this equation, resultant velocity V equals, result velocity V equals, learn from every question, equals root 100 squared plus 50 squared. What is the value of 100 squared means 10,000. 50 squared means 2,500. 10,000 plus 2,500 how much? 12,500. Simplified. Simplified. Next week, bring a logbook. You should practice log. Now look at the way that I am simplifying. So what I am doing, see, now 12,500 means we know 125 into 100, right? 12,500 means 125 into 100. 125 means you know that 125 means 25 into 5. 25 into 5 means 25 into 5, correct? 125 means 25 into 5 into 100. So I am putting that 25 into 5 into 100. Now you can separately get this root. Root 25 into root 5 into root 100 all level. What is the root value of 25? 5. Root value of root 5 means you want to use something. Root 100 means 10. The final answer will be 50 root 5. 50 root 5. M is minus 1. M is minus 1. But you should find the root 5 value. Should find the root 5 value. So if you don't know how to find these root values, next week didn't I teach you? I taught you, right? I taught you, right? Or I taught you, but if you guys have a doubt, put a reply. So then we'll do it. Now, is it enough? Okay, I'll ask a question. Now, they are asking us to find the final velocity at 15 seconds. Is it only enough to find the velocity? We want to find the direction as well, because vector has magnitude as well as direction. Now, you found 50 root 5 means magnitude of final velocity. You found V, but you want to find the angle also. You want to find the angle also. How to find the angle? I consider this angle as alpha. Then you can remember vectors. If this angle is alpha, I told you what? How to find tan alpha? Tell me. If this angle is alpha, horizontal component V1 and vertical component V2 means, how do you find tan alpha? I told you to move V2, this line. I told you to move this V2 line, straight line to here. When I was explaining vectors, I taught you. Then what is your tan alpha? Tan alpha means V2 over V1. Tan alpha means V2 over V1. Very similar way, if you follow tan alpha. What is your tan alpha? Who's the front one? 50. Opposite over adjacent, 100. Tan alpha means what? 50 over 100. That means tan alpha means 0.5. When we subject alpha, alpha means tan inverse 0.5. I will teach you how to find these angles also. So don't worry how to find this 50√5 answer, and don't worry how to find this angle. I will teach you. Up to now, this question, everything is very clear answer. This question, if you understand everything, okay, raise your hands. Okay, that is done. Okay, next question, question number 18. Hands up who needs some time to do question number 18? No, if not, we'll do 19. We'll do 19. Do 19, take that angle is not 25. 19, take the angle as 30. 19, take the angle as 30. Start doing 90. Hands up who needs, okay, I will give some 5 minutes. But please get the answer. Don't waste the time that I give you. I'm assuming these you people who are engaging now, you guys, I'm assuming you guys really working. So therefore, I'm giving some time. Now time is exactly 11:16, 11:20, 21. I will start explaining. Start doing that question number 19. 19, take that angle as 30. Don't take it as 25. Take the angle as 30. Do it.
Yeah, so that 60 time root 3 or 2 no. Yes. But if I use the vertical motion, I will get it easy. But displacement full of the time. Anyway, you will get you only indicate the motion. Where another very specific horizontal rate is horizontal rate. Horizontal rate is horizontal normally that is horizontal. I don't picture only. Horizontal part time, every part of it all. In the case of in the case of it's equal to. I asked my horizontal photo, it's equal to. In the picture, yes, the color will be boring. Horizontal is the area. In the picture, right? I don't know. Vertical vertically power. Vertical power is time of on the time horizontally power. Really power. Million 100 take time
முதல்ல vertical time கண்டுபிடிச்சிட்டு அந்த டைம் horizontal அதான் கேக்குது அதே விஷயம்.
Now in this question, the idea is now they are asking us to find the horizontal range. Whenever, if you want to find horizontal distance or displacement, you want to definitely consider equivalent horizontal motion. Last day I was explaining, if you are considering equivalent horizontal motion, only equation you should apply is S equals ut. But the problem is now you must consider equivalent horizontal motion, you must apply S equals ut. Your target is finding S only. You know horizontal velocity component, but you don't know the time actual. Time taken for the motion, you don't know. In that case, you should find the time again considering equivalent vertical motion as. So in this question, you should consider equivalent horizontal motion. You want to apply S equals ut. You want to consider equivalent vertical motion, and you want to apply best linear motion equation, and you want to find the time as well. So you should consider both the motions. Then only you can get the answer. So I will also, now time is, yes, I will also starting. Now time is 5 minutes finished. And Sabu got the answer, anyone? Anyone got the answer? Did anyone got the answer? So I'm also doing now. Question number 18. Question number 18. Question number 18. Max, not 18, 19. Ball is throwing up from the top of a building, height 35 meter, making an angle 30 degree with the horizontal. If the velocity of the projection is 60, what is the maximum horizontal distance it covers? Maximum horizontal distance, 35 meter. 35 meter high building. Question number 19. Question number 19. Building object, projectile motion, projection angle 30 degree. So I consider initial point as point A. This is the final point where object hits the ground. This point is point B. Height of the building 35 meter, height of the building 35 meters. 35 meters height of the building. Given data, projection velocity is given. Projection velocity is given, that is 60. Want to find R. 60 m is minus 1, want to find R. Want to find capital R. How can I find capital R? So now you know that horizontal range is capital R. When we want to find horizontal distance, you want to consider equivalent horizontal motion. From A to B, if you consider equivalent horizontal motion from A to B, only equation we want to apply is, I told you, S equals ut. What direction? Right direction. S equals ut. Then horizontal distance is capital R. Your target is finding capital R. What is the U? U means, now if you consider equivalent horizontal motion, What is u? U means horizontal velocity component. Don't forget that to think that one. Don't forget to think that one. When you consider equivalent horizontal motion, u means, remember, always horizontal velocity component. If you are considering equivalent vertical motion, u means vertical velocity component. What is the horizontal velocity component throughout the motion? 60 cos 30. Right? 60 cos 30. I hope you understand. Your u means 60 cos 30. The problem is what? Your target is finding capital R. The problem is, unfortunately, you don't know time taken to move from A to B. You don't know. Time taken to move from A to B, I mark it as capital T. Capital T. If you can find the capital T, you can find R. The problem is you don't know T. Now what's my target? I want to find R only, but I don't know T. Now my target must be finding T first. If I find T first, then I can find R. How are you going to find T now? How are you going to find T now? In this case, again, you want to consider equivalent vertical motion. If you are finding T, you want to consider equivalent vertical motion from A to B. Again, I am considering equivalent vertical motion from A to B. If I do the sketch of vertical motion, ground, initially object is at A, object is going like this. Equivalent vertical motion, object is going upwards and coming down, equivalent vertical motion. Equivalent vertical motion. This is the equivalent vertical motion. Am I correct? Initial object is going upwards. What is the initial vertical velocity component when you consider equivalent vertical motion? What is the initial vertical velocity component? 60 cos 30 horizontal velocity component, 60 sin 30 vertical velocity component. Vertical velocity component VVC is 60 sin 30. What is the value of sin 30? You know it's half. Then vertical velocity component initially 30 m is minus 1. When you consider equivalent vertical motion, always don't, please understand what I mean by equivalent vertical velocity, equivalent vertical motion. What I mean by equivalent vertical velocity. Initial vertical velocity is how much? 60 sin 30. That means 30 m is minus 1. Initial point is A in the vertical motion. Final point is point B. What is the vertical displacement from A to B? Vertical displacement from A to B. Vertical displacement from A to B will be 35 downwards. 35 meter downwards. Initial point is A is here. Final point B is here. Displacement from A to B is 35 downwards. Gravitational acceleration 10 m is minus 2. That is also downwards. Gravitational acceleration also downwards. Okay. Then I know U 30 upwards. Gravitational acceleration A downwards. 35 S downwards. If I want to find the time taken to move from A to B, capital T, my target is finding T now. What is the best equation? S equals ut plus half a squared. Hands up, how many of you applied S equals ut plus half a squared for this so far? Hands up. Hands up. I think most of you now you know the pattern, right? I think now you know the pattern. So therefore, come to the online classes daily. Don't try to watch the recordings all the time. It's not good. Please engage. Engage. You should have a concern about your teacher also. I think that now you can come to a conclusion about your teacher because we are doing the classes for 3-4 months. And I think you know the routing also. What's my routing? How I teach? How I explain? Now, what's my priority? You know that I don't provide jokes or anything. I no need to provide joke also. I don't want to maintain a crowd by putting joke. That's not my job. My job is teaching the concept, making A results. That's my target. So normally in my classes, that's the way. So I don't need to give any introduction about me now. You know who I am now. Because you are working with me for 3 months, you know whether I'm good or bad. You know that. I know that I am good in explaining. I know that. So I'm applying S equals ut plus half at squared in the initial direction of the motion upwards. Initially, this one is going upwards. In the initial direction of motion, I'm applying S equals ut plus half at squared. And then, as I'm applying the equation in upward direction, vertical displacement is downwards. Then, minus 35. Hands up. How many of you substituted minus 35 hands? How many substituted minus 35 hands? I think most of you might have substituted plus 35, right? But you know, right, because we are applying this equation upward direction, but displacement is initial to final downwards. Minus 35 equals, what is your initial vertical velocity? 30. Some people substitute still 60. I don't know why. 60 is the projection velocity. But when you are considering equivalent vertical motion, you want to consider initial vertical velocity component. That is 30. Time is capital T. Time is capital T. Plus half. Acceleration again minus 10. Acceleration is minus 10. Time is capital T squared. Simplification. So minus 35, 30 minus 5t squared. So what can I do? I can divide all. Now look, I'm not following the steps, everything. Minus 35, 30t minus 5t squared. I can divide all of them by 5. Then I am getting here, if I divide minus 35 by 5, minus 7. If I divide 30t by 5, 60. If I divide minus 10 over 2 means minus 5. If I divide minus 5 by 5, minus 1. Capital T squared. Quadratic equations. Hands up who found capital T so far? Anyone? There are factors. There are factors. Move 60 to the left. Minus T squared to the left. Then we are ending with T squared minus 60 minus 7. You are ending with T squared minus 60 minus 7 must be equal to 0. Hereafter quadratic equation. What are the factors? Factors minus 7 plus 1. Factors minus 7 plus 1. Factors T squared minus 70 plus T minus 7 must be equal to 0. Get the factors. When you get the factors, problem solved. If you know the T, you know the R. Got the answer. So then you are waiting what to be done next. Next question, you are waiting for that. Then if you finish doing this question, you do do 20 and do 20 and 20 and 8. Do 20 then 8. 20 then 8. What you asked? Sorry? Root 3 means 1.732. Root 3 means 1.732. Okay, common factors. Common factors. So I can take common factor T. This pair, these two pair. T is the common factor. Common factor, if I take T as my common factor, then T minus 7. These two pair means plus 1. T minus 7 must be equal to 0. Then I can write down T minus 7. After doing this projectile motion graph, you get a beautiful knowledge. So that knowledge you can argue. Now see. So T plus 1, T minus 7. T minus 7. So finally we can write down, because there are two answers, but one answer is not possible. First answer is T equals 7 seconds. Other one is T equals minus 1. That's wrong. First answer is T equals 7 seconds. Other answer is T equals minus 1, because time can't be negative. Therefore, right answer is T 7 seconds. And now substitute in equation 1. And now you can write down, I want to find Yes. Huh? Then you guys select something and keep on doing. Right. Okay. So where we stopped? Actually, we were finding that capital R, okay, now capital R from equation 1, capital R equals how much? Capital R means we know 600 cos 30. How many of you finished finding R? Hands up. Hands up. How many of you finished finding R? Hands up. Finished finding R. Okay, keep on doing. Then find after doing, start doing 28. Keep on doing. Then 60 cos 30. 60 cos 30 into time capital T I found, it is 7 seconds. Then 60 cos 30 value, you can remember it's root 3 over 2 into 7. So then 60 over 2 means 60 over 2 means 30. 30 into 7 means how much? 210. Root 3. This is the answer, right? Then root 3 value 1.732. Then capital R is how much finally? So one is telling 360 something. I will put that answer. You guys check if it is wrong, tell me. If your answer is deviating from that answer, tell me. 363.72. This is the answer. If it is wrong, tell me. Meters. Meters. Question number 19 done. 19 done. So I'm going 20. Hands up, how many of you started? 20 hands up. 20 started. 20 started. 20. Now I'm starting 20 also. 11 done, 18 done, 19 done. I'm starting 20. $20. What they're asking? 20. A bullet is fired horizontally with a velocity 120 ms minus 1 from top of a building of height 500 meter. Calculate the time taken to reach the ground, horizontal distance to the point of landing from the building. Bullet is fired horizontally with a velocity 120 ms minus 1. Question number 20. $500-meter building. 500-meter building. My bullet projected horizontally. Horizontal velocity how much? 120 ms minus 1. 120. I will ask you one question. I will ask you, first question is, raise your hands, how many of you say, if this bullet is projected horizontally with 120 ms minus 1, this bullet keep on moving horizontally, hands up? It's moving in a path like this, a projectile path like this, hands up? So this bullet is moving not horizontally, actually this bullet is moving a projectile path like this. So keep that in your mind. Then I'm asking one question. What is the initial vertical velocity component? Reply in that box. What is the initial vertical velocity component? Reply. What is the initial vertical velocity component? Reply. Anyone have idea? Initially, bullet is moving horizontally. Initial horizontally moving. Then what is the initial vertical velocity component? Any answer? No answer yet? No answer yet. Remember, if initially bullet is moving horizontally, remember, initial vertical velocity component must be 0. Red color pen important write down. Red color pen important write down. If the bullet is projected horizontally initially, if the bullet is projected horizontally, red color pen, if the bullet is projected horizontally, comma, the initial vertical velocity component, the initial vertical velocity component, the initial vertical velocity component is 0. Is 0. Is 0. And now we can do it. Now what they are asking? They are asking time taken, capital R. I want to find horizontal range and I want to find the time taken, capital T. If I can find capital T when I consider equivalent vertical motion, I can find capital R when I consider equivalent horizontal motion. I consider A to B motion. This point is, initial point is A. Final point will be B. Equivalent vertical motion A to B. A to B. Shall we draw the vertical motion for our understanding? Equivalent vertical motion for our understanding if I draw the sketch. Not compulsory to draw the sketch, but for your understanding only I am drawing. In future, I don't do this much of explanation. I don't give also actually. Until your brain start work. My ground, equivalent vertical motion, initial vertical velocity, I told you. Equivalent vertical motion, initial vertical velocity is 0. Want to find the time, acceleration, gravitational acceleration, vertical displacement from A to B, 500 meter downwards, 500 meter downwards. I want to find capital T. Want to find capital T. Target. Base linear motion equation, S equals ut plus half at squared. In the initial direction of motion downwards, if I consider equivalent vertical motion, object is going down. So therefore, downward direction, S equals ut plus half at squared. Downward direction, S equals ut plus half at squared. What is your S? What is your S? Downward 500. So therefore, plus 500. Your initial vertical velocity, 0, 0 in a time means 0, plus half, acceleration also in downward direction, my motion also in downward direction, therefore plus 10, time taken capital T. Time taken capital T. So then 10 over 2 means 5, 5t squared. 500 equals 5t squared. So when you subject t squared means 100. 500 over 5 means 100. T squared is 100. Then what is t? T means 10. T squared is 100. Then what is your t? T must be 10 seconds. We found the time. And not only finding the time is enough, but we want to find the horizontal range. This time I'm considering equivalent horizontal motion from A to B. Only equation we are applying for equivalent horizontal motion is S equals ut. S equals ut. S equals ut. Hands up who found the answer already answer? Who found the answer for R? Hands up already found the answer? Found the answer. Only one? 12 o'clock, 1 hour to go. The time is 12 o'clock. Okay, let's go with a small poll. Today, time went so quickly. Answer. Okay, there are three possible answers. Today, time went so quickly. Time went as usual. Today, time is going so slowly. Time went so quickly. Answer. Went quickly for you. Yes, 1 hour there. Most of it. Time went normal way. Time went normal. Today, time is going so slowly. I don't know why. Here to go with that poll. Okay. R is, what is my U? Horizontal velocity. Horizontal velocity throughout the motion is 120. Any point on the horizontal motion, horizontal velocity is 120. 120, time taken is 10. R is 1200. You got 1200? 1200 meters. R. That answer is done. Question number 20 discussed. Question number 8. Start doing 8. Start doing 8. So when I do weight, 8th one. Ball is projected from the ground with a speed of 25 ms minus 1. 2 seconds later, it just clears the wall 5 meter high. Angle of projection, maximum height. How far beyond the wall? Ball again. That's a good question. Question number 8 also very good question. Idea is same, but question to question it's different. Question number 8 also a good question. Question number 8. That is also a good question. 8th one. Now almost next week we can start projectile, sorry, we can start motion graphs. We can start motion graphs. Then kinematics almost finished. Then relative motion part is a small part. Then kinematic finished. You need one measuring instrument part. I didn't do the practical part. I didn't do that part is there. So I will arrange a small seminar and so I will buy some vernier calipers and micrometers and we'll do that practical physically in the class. If you can come, then come. And I will online also, I will stream it. We'll do in that way, practicals. Question number 8. Projectile motion. But the problem is they haven't given projection angle. That's the problem. In question number 8, ball projected from the ground, speed 25 ms minus 1, but projection angle not given. Projection angle, I mark it as theta. I mark it as theta. You got this 8th one you finished doing? 8th one? You are in the B part. So then, if I draw the projectile motion, this is the projectile motion. This point belongs to the maximum height point. We know at the maximum height, we know vertical velocity component is 0. Right. What else they are saying? 2 seconds later, it just clears a wall of 5 meters high. When t equals 0, object is projected. I understand. 2 seconds later, this object clears a wall 5 meters high. The problem is, I don't know where is the object when the time is 2 seconds. When the time is 2 seconds, actually, this object can be somewhere here. When the time is 2 seconds, maybe object will be somewhere here. So I don't know where is the object actually. Where is the object actually? The time is 2 seconds. They are telling there's a wall. 2 seconds later, object just passing on top of the wall. Just clears the wall. That means when the time is 2 seconds, object is almost touching the top surface of the wall. I tell when the time is 2 seconds, here is my object. In the projectile path, when the time is 2 seconds, here is my object. So just clears a wall means just touching the wall and going. And then my wall must be somewhere here. Am I correct? So I draw my wall. This is my wall. So why they are talking something about wall? They are telling when the time is 2 seconds, vertical height is 5 meters. That's what you want to get it. This is the wall. So what is the idea? You should get it. When the time is 2 seconds, corresponding vertical height to the object from the ground is 5 meters. That's the idea. That's it. So this wall is 5 meters. That means vertical height is 5 meters. Vertical height is 5 meters. Okay. Just place a wall. Okay. Time is 2 seconds. Okay. This is the given data. But I'm not sure. I don't know. When the time is 2 seconds, I don't know object is here or here. Suppose if the object is here, here is my wall. It's okay, no issue. It's no issue, nothing harmful for the question. They are asking angle of projection angle. They are asking projection angle. How can we find the projection angle? How can we find the projection angle? Any idea? I want to find projection angle. So this point, when t equals 0, initial point is point A. When time is 2 seconds, that point I marked as point B. Maximum height point I marked as point C. I want to find the theta. So how can I find the theta? Any idea? How can I find theta now? You want to consider a motion from A to BO, A to CO, B to CO, I don't mind. And you want to consider equivalent vertical motion or equivalent horizontal motion, and you have to find theta. First of all, in terms of theta, if I resolve 25 into two perpendicular components, horizontal velocity component will be 25 cos theta, horizontal velocity initial at A. Initial horizontal velocity component will be 25 cos theta. Vertical velocity component will be 25 sin theta. Initial vertical velocity component will be 25 sin theta. My target is finding theta. Any idea? Hands up who found theta already? Anyone? Anyone found theta already? Hands up. Are there someone? Hands up who needs some time to find theta. Hands up. Hands up. How many of you need some time to find theta? Hands up. You need time? Hands up. How many of you need some time to find theta? Hands up. If you need some time, tell me. No need. Time, no need. Can someone reply? Hands up who have the idea to find theta? How? Hands up who have the idea to find theta? Hands up. Hands up who have the idea to find theta. What should we do? Any idea? Any idea? No idea. Consider A to B motion. Equivalent vertical motion. So then you can get the answer. But decide the equation properly. Consider equivalent vertical motion from A to B. Then what you know? If I do the sketch, A to B vertical motion, A to B vertical motion, vertical displacement is 5 meters. Vertical displacement 5 meters. What is the initial vertical velocity component? 25 sine theta. So this is 25 sine theta. Initial vertical velocity component 25 sine theta. Acceleration 10 m is minus 2. Acceleration 10 m is minus 2. Also time taken, t equals 0 here, t equals 2 seconds here. You know the time, you know the acceleration, you know the displacement. Can't you find theta? You want to involve equation u s a t. Yeah, s equals ut plus half a t squared. Same equation. S equals ut plus half a t squared equation. Apply and get the answer. S equals ut plus half a t squared. Apply, get the answer. How many of you already applied S equals ut plus half a t squared answer? Already applied S equals ut plus half a t squared. A to B. Then can get the answer. Then get the answer. Upward direction. S equals ut plus half a t squared. S how much? Vertical displacement 5 meters. U how much? 25 sine. You want to find the angle theta. You want to find the angle theta. Time taken is how much? Time taken is 2 seconds. Plus half. Acceleration, gravitational acceleration downward minus 10. Time is 2 squared. Time is 2 squared. Can do. Get the answer. Can do, get the answer. Then when I simplify this, get the answer. 5 equals 25 into 2 means how much? 50. 50 into sine 50 into sine theta. Then how? 50 into sine theta. Now 1, 2, 1, 2 cancel out. Minus 20. When minus 20 goes to the left, plus 20 plus 5, 25. Minus 20 go to the left, plus 20 plus 5 means 25. 25 must be equal to 50 sine theta. Subject sine theta. When you subject sine theta will be sine theta will be 25 over 50. 25 over 50. That means half. Sine theta means half actually. Tell me then what should be the angle theta? Sine theta half means you know what is the sine angle corresponding to half? What is the sine angle corresponding to half? Third degrees, right? Sine theta half means sine angle corresponding to half means 30. Right? And tell me now, after all result is coming. All the result is coming. I might start for different class. Not this class. This class is continuing further. So if there are some new students coming, or if you have any friends, till after all result come, mostly second week coming results. Results coming second week or third week. So then, as soon as result come, we are starting a separate class. Not this time. This time we are doing continuously. We are doing. And people who missed the previous sections, they can cover from that class. Sine for them, okay, sine 30. Sine cancel out, theta equals 30. So this is the idea. So learn, every question you learn. Theta equals 30. Need a break? Need a break? No need, right? Theta equals 30. Today we are doing from 19. So far class is effective. So far, I think that class is effective so far. So we have done plenty of questions. So very good questions we have done. 12, 10, exactly 3 hours we had on the class. Hands up, hold a break now. We'll take a 5-minute break. Hands up. We'll take a 5-minute break. Hands up. We'll take a 5-minute break. Hands up if you need. So no one is telling no need. That means you don't need a break. Found the angle. Then they're asking what? Then they're asking maximum height attained. Now we know the angle. This angle is 30. Now we can find the maximum height. If you know the angle, if you consider equivalent vertical motion, problem solved. Now you guys can find the maximum height. Hands up who found the maximum height? Maximum height found, hands up already. So there is one. Who else found maximum height already? Finding, hands up, finding. I am finding maximum height, hands up. I am finding. Currently I am finding maximum height. Currently I am finding maximum height. Okay. So then simple B. Again, if I consider A to C equivalent vertical motion. Equivalent vertical motion from A to C. From A to C. A to C equivalent vertical motion. If I do the diagram, initial vertical velocity. Now, what's the initial vertical velocity? 25 sine theta. That means 25 sine 30. Now, you know vertical velocity is 25 sine 30. 25 sine 30. At the maximum, now A to C, at point C, vertical velocity is 0. I want to find the height. I want to find the height, simple H. I want to find simple H. How can I find simple H? Acceleration is 10. I know U, I know V0, I know A, I want to find S. V squared equals U squared plus 2AS, upward direction. Upward direction, V squared equals U squared plus 2AS. That is the equation. Upward direction, V squared equals U squared plus 2AS. Final velocity is 0. Initial velocity is 25 sine 30. Sine 30 means half. Then 25 sine 30 means how much? 25 sine 30 means half. 25 over 2, right? So 25 over 2 whole squared plus 2, acceleration downwards minus 10, height simple H. Height simple H. Am I correct? Height simple H. Subject H. When you subject H, you get the answer. When you subject H, you get the answer. So then you are getting, now see, 2 into minus 10. That means minus 20H. Minus 20H, move to left. It will become plus 20H. 2 into minus 10 means minus 20. Minus 20h moved left. 20h. 20h equals 25 squared over 2. 25 squared over 2 squared. 25 over 2 squared. 25 over 2 squared means 25 squared over 2 squared. You can separately give the power. 25 squared over 2 squared. Then how much? 25 into 25. 2 squared means 4. If you subject simple h, what is the answer? What you got? What you got? 7.881. We'll see. So then I can divide. I can divide by 5. If I divide by 5, 4, yeah, 5. Then I am getting 25 into 5 means 125. 4 into 4 means 16. 125 or 16. You got 125, 16, 7.81 is the answer. Hands up, who got 7.81 meters? 7.81 meters. Anyone got the answer? Now always keep your focus. That's what I can say. That's what I can say. Now we are in a vision. We are in a mission of getting A. Think always that. I am supporting you. I am guiding you. Always think that between you and me, no one else. So we are discussing. We are learning. Right? Don't make yourself tired. This 4 hour, commit yourself. After class finishes, go and sleep, take a rest, eat, do whatever you want. But when you are in the class, don't do anything else, even though it's tired. Always tell to yourself until last second, your focus must be there. Focus it. Focus it. Because I know that, do you have any time to redo these questions again? Now you guys might have the time to redo these questions again. But remember, when you get more older, after 6-7 months, what will happen? They start paper classes for you. Then school term test, daily you want to go to school. Sometimes now we are not going to school daily also. Daily you want to go to school. After school there are classes. Also there are paper classes. Now currently you are following only 3 classes for 3 subjects. Then when paper classes coming, there are 6 classes you have to follow. You want to go to schools also. Then you don't have time. So therefore remember, so don't now. Therefore you don't have time to do these questions again. So when you are doing in the class these questions, stay focused. If you stay focused and if you understand what's the problem and mistakes, you don't have to spend another time to do these questions again. So therefore get that. We'll take a small break and come. So for only now last break we took at what time? Not just now. I think at what time I gave the break? I gave the break at we started 9:50. Somehow I gave the break at 9, not 9. I gave 15-minute break. 9:35, 9:33. I give the break. I give the break at 9:33, 9:50, 10:50. You guys came at 9:50. No. I gave the break at 9:50. No. I give the break at 9:33. Yes, see. I gave the break at 10:33. Right. I gave the break at 10:33, then 10:50, 10:50, 11:50. Yeah, 1.5 hours has gone. We'll take a small break and come. So now time is 12:18. 10-minute break. 12:28. We'll start back. We'll do until 12:55 today. Half an hour. Only half an hour to go. Today I think class is effective so far. Yes, half an hour to go. Yes, we'll start. Okay, we found the maximum height as well. Then last they're asking, what they're asking, simple C in that question. Last they're asking, how far beyond the wall, ball again hits the ground. How far beyond the wall, ball again hits the ground. Okay, the last part. The last part. Okay. So now I am quickly doing the remaining as soon as possible. Okay. So half hour to go, class will be finished in half an hour. Okay. They are asking this distance. How far beyond the wall, ball again hits the ground. Beyond the wall. Beyond the wall means you want to find this horizontal distance. I put it as simple x. Right? You want to find this horizontal distance, simple x. That's what you want to find actually. Now, very clear, if you want to find this horizontal distance, simple x, you should find overall horizontal distance from here to here. Right? You want to find A to this point. And you should find the horizontal distance from here to here. Then only when you subtract total horizontal distance minus this horizontal distance, you can get the answer. Am I correct? So therefore, what I thought is, I thought of considering A to B motion equivalent horizontal motion. The last part C, A to B equivalent horizontal motion. I apply S equals UT equation. S equals UT. I say that the horizontal distance from A to B, I mark it as Y. Horizontal distance from A to B, I mark it as Y. Then Y equals horizontal velocity component. How much horizontal velocity component? 25 cos 30. 25 cos 30. Time taken to move from A to B, you know, time taken to move from A to B, it's 2 seconds. 2 seconds. So then 25 cos 30 means root 3 over 2 into 2. So then this 2 cancel out. 25 root 3 is my Y value. So we'll substitute 1.73 to later. Now just keep your Y as 25 root 3. I found Y okay. But my target is to find X. My target is to find X. So therefore, I want to consider entire projectile motion. If I consider entire projectile motion, now there are many steps. Now, I am considering entire projectile motion. For the entire projectile motion, A to D entire projectile motion, if I consider equivalent horizontal motion, S equals UT equation. What is the horizontal range when you consider entire projectile motion? Horizontal range, entire projectile motion, horizontal range, I can consider X plus Y, right? Entire projectile motion, horizontal range, X plus Y. My target is finding X. My target is finding X. I know value of Y, I know X plus Y, I know value of Y, I found. Horizontal velocity component, 25, cos 30 only. The problem is, do I know the total time taken for the entire projectile motion? I know the time taken to move from A to B. I don't know time taken to move from A to D. Entire projectile motion time, I don't. I want to find X. I know Y. Total time taken for the projectile motion, I don't know. I don't know. Then again, there's a headache now. If I want to find the time again, what I want to do? Any idea? Can someone tell me? If I want to find the time now, I want to consider again entire projectile motion. I want to consider equivalent vertical motion. See, that's the problem. I want to find x. I found y. Entire horizontal motion. I found this equation. I don't know time again. If I want to find time again, I want to consider entire projectile motion and I want to consider equivalent vertical motion. It's a headache, but what to do? What to do? Hands up, who did these things already? Hands up. Any online people? You got this idea? How many of you doing this idea? You got this idea and doing with these hands? Only one is raising. I don't know what others. Okay. Equivalent vertical motion from A to D. I'll ask you, when you consider entire projectile motion, if you consider equivalent vertical motion, what will be your vertical displacement? Put the answer in chat box. If you consider entire projectile motion, corresponding equivalent vertical motion, what is the total displacement? Vertical displacement. Answer? Anyone? 0. 0. Very good. 0. Okay. Equivalent vertical motion. Initially, object is here at A. Finally, at D. So, overall displacement 0. Acceleration, gravitational acceleration. Want to find the time? Want to find the time? Vertical velocity, you know, initial vertical velocity is 25 sine 30. 25 sine 30 vertical velocity. Want for the time? S equals ut plus half at square. If you understand, you can do it. Huh? And please, after class finishes, I need from all of you, people who coming, just better you put a feedback. You send a feedback. Better you put negatives and drawbacks. Also notice what you, the positives also include. S equals ut plus half at squared. Displacement 0. Velocity, vertical velocity, 25 sine 30. 25 sine 30. Time taken, capital T. See, so many simplifications. So many simplifications. Plus half acceleration minus 10. Again, time is capital T. Time is capital T squared. Find time here, substitute here, you can find x. X. 0 equals 25 sine 30 means half. Capital T. Minus 10 over 2 means minus 5 capital T squared. Minus 5 capital T squared. Minus 5 capital T squared when you move to the left. 5 capital T squared. 5 capital T squared must be equal to 25 over 2, 25 over 2 capital T. 25 over 2 capital T. 1 capital T cancel out. Capital T will be equal to 25 over 2 into 5. That means how much? You can divide 5 over 2 means 2.5 seconds. 2.5 seconds. 2.5 seconds capital T. Now substitute in that equation 2. You get the answer. And now you can substitute in the equation 2. You can write down x. You want to find x only. What is your y value? You found your y as 25 root 3. X plus Your y is 25 root 3, 25 cos 30 means how much? Root 3 over 2 into time is 2.5 seconds. 2.5 seconds. Practice these questions again. Then you get a better understanding. Practice this again, then you get a better understanding. 1240. 1240. Simplify it. When you simplify it, you are ending with what? So when you simplify it, now 2.5 over 2 means 2.5 over 2 means, it's 1.25. 25 root 3. 2.5 over 2 means 1.25. Am I correct? Then x plus 25 root 3. X plus 25 root 3. The when you subject x, what will be your x? 25 root 3 into 1.25 minus 25 root 3. Am I correct? Now learn these sums. Learn these sums. Now what I look the way that I am to this question. After hands up, until now everything is very clear. Hands up. Until now, everything is very clear. Raise your hands. Until now, everything is very clear. Raise your hands. Now see what I'm going to do is, what I'm going to do now. I am taking common factor. There are two terms. I'm going to take my common factor as 2 root 3. What I'm getting in the brackets, if I take 2 root 3 my common factor, 1.25 minus, if I take 25 root 3 as my common factor, what is remaining? 1 is remaining. Then I can write down 2 root 3 into 1.25 minus 1 means how much? 0.25. See the way I'm simplifying. 2 root 3, 0.25 means what? It's 1 over 4. That means you know that 2 root 3 over 4. You can divide by 2. 1, 2. Then you are getting root 3 over 2. I taught you root 3 means how much? 1.732 over 2. What is the final answer? Final x will be 0.866 meters. Got it. Got it. You got that answer? 0.866. This x, the last C part in that question number, we are doing question number 8 or something, C part. What is your that beyond the wall horizontal distance? No, this one, this is correct. This is the answer. 2 root 3. So then your answer might be wrong. Check this. What is the time now? Now time is 12:41. 12:41. Shall we do one more question? Because it will take another 10 minutes. One more question. We'll go with the poll. Shall we go with the poll? Now, first poll is the time is 12:40. As we did enough questions, we can stop now. That is poll 1. Second poll, sir, better we'll do one question and we'll stop the class. So we'll do one question, we'll stop the class, option 2. How many of you going with poll? Genuinely, I don't mind. Okay. So if you like to go with poll 1, poll 1. If you are not like to go with poll, if you like to go with poll 2, poll 2. How many of you going with first option answer? So we'll stop the class today, hands up. Now, enough. Hands up. No one is raising hands. That much of good students are there. We'll go with option 2. We'll do one more question, we'll stop the class. That much of good students. Okay, very good. Okay, we'll do one last question for today. We discussed 8. And shall I do ninth one? Start doing ninth one. Start doing 9. Start doing ninth one. Question number 9. Start doing 9.
Oh, 21.7 because 25 was 30.
Oh.
So then after that I multiply with 0.5 10.8.
0.5 is the n multiplied by
Now, initially 74 seconds.
Oh.
Total time 2.5.
Total time 2.5 per day.
Yeah.
2.5.
So I
Oh.
multiply this by 0.5, then I get 10.88. I accidentally multiplied first by 2.5. Total time I multiplied by 6.95. And also, other divide பண்ணா 0.6.
Oh, 0.86.
So initially 43 meters.
43 meters?
Yeah, because yeah, 25 plus 30 into 2 seconds. That will give you 43.55 meters. Initially 7.
Horizontal?
Yeah, 25 cos 30 into 2 seconds.
Cos 30 is equal to divided by cos 30. ಇಲ್ಲ ಸೆವರು ಉಮ್ಮೇಲಿಗೆ ಆವಣಿಗೆ ಸೆವರಿಗೆ ಆಣಿಗೆ ಸೆವರ ಮುನಿಗೆ ಇಂತ ಬಹುದಿಲ್ಲ ಸೆವರು ಉಮ್ಮೇಲೆ ಅಂಚೆ ಅದ ಬಹುದಾಗಿ ಸೆವರು ಸರಿಯಾ ಪಾತ ಸರಿಯಾ Total horizontal limit பாருங்க சரிவா நான் செவர் வந்து அந்த டி பாயிண்ட் இருக்கு பாயிண்ட் உள்ள தான் இருக்கு செவர் இருக்கு இந்த பாயிண்ட் கிட்ட தான் செவர் இருக்கிறாங்க அப்படி செஞ்சா இருக்கு போல அப்ப நீங்க பண்ணிக்கிற
x plus y equals 25 plus 30 அதே நம்பர் s equals to equation.
ஓ ஃபுல் மோஷன் எடுத்தா x plus y தானே horizontal u வந்து 25 cos 30 டைம் வந்து total time t y வந்து இங்க இருந்து செவருக்கு வந்து y அது நான் கண்டுபிடிச்சேன் y வந்து எவ்வளவு 25 root 3 y
25 root 3
அது 75 வரல ஓ நீ செஞ்சது கூட பாக்கலாம்
so it is 43.9.
ஓ ஐ சாரி यार கடல் சேர்க்கணும்
Sir, you 2 root 3 and 25 root 3. And the 25 root 3 into 2 root 3 and
okay now here I made a mistake okay here I made a mistake look here instead of look here instead of putting 25 root 3 here I have put 2 root 3 I made a mistake so here it must be 25 then hereafter wrong so 25 root 3 over 4 then 25 into root 3 means 1.732 over 4 so then your final answer must be how much 10.88 then final answer must be 10.88 meters. Okay, I made a mistake. Huh? Right. Okay. So we'll do the last question number 9. Did you do 9? Do 9 and we'll finish today. We'll do 9. Last question. 9th one, they are saying man throws a shot angle 45 degree with the horizontal from height 1.5. Shot strikes the ground, horizontal distance 30, projection velocity. So we'll do 9. We'll do 9th one. Question number 9. This height is 1.5 meters. 1.5 meters. Projection velocity, we don't know. That's what we want to find actually. Projection velocity, I will mark it as simple x. I want to find the projection velocity simple x. That's my target. Projection angle is given as 45 degree. Projection angle is given as 45 degree. Okay. Then this one is moving the projectile motion like this. From the projection point A to point B, they given horizontal velocity how much? They given horizontal velocity, horizontal distance how much? 30 meters. So your target is finding x projection velocity. This is 30 meters. So what you can do, you can consider equivalent horizontal motion from A to B. What you can do? A to B, your target is finding x actually. A to B, equivalent horizontal motion, you can apply S equals ut. You can apply S equals ut. Horizontal distance 30. Horizontal velocity component x cos 45. X, you want to find x only. Cos 45, the problem is you don't know the time. X cos 45, time taken is capital T. Time taken to move from A to B, we'll mark it as capital T. You don't know time also. The target is finding x, but you don't know capital T as well. Now remember here, x is projection velocity. There are two unknowns in one equation. This will be equation 1. Again, you want to consider equivalent vertical motion from A to B. Equivalent vertical motion from A to B. Then, if I draw the diagram, at A, here is object is at A. At A, vertical velocity is x sine 45. At A, vertical velocity is how much? X sine 45. Vertical displacement 1.5 meter downwards. A to B, vertical displacement 1.5 meter downwards. Acceleration, gravitational acceleration 10 ms minus 2. So I know I want to find x. Time taken is capital T. Time taken capital T. Again, same thing. S equals ut plus half at square. Am I correct? S equals ut plus half at square. A to B. A to B, yeah? Initially going upwards. A to B is equals ut plus half at square. Upward direction. What is S? S how much? Now I'm applying the equation upward direction, then S must be minus 1.5. Am I correct? S must be minus 1.5. U is how much? X sine 45. U means x sine 45. X sine 45. So go home and do these questions again. Don't forget to send the feedback. Huh? Time is capital T. Time is capital T. Plus half. I'm applying upward direction, acceleration downwards. Minus 10. Minus 10. Again, time is capital T squared. My target is finding x. Time is capital T squared. You did these two equations. You got it? Okay, do this question quickly. Now what can we do now? Now we took two equations. What can we do? Target is finding x. So therefore, you can do something like this. So you can substitute. Now I thought of my target is finding x. I thought of subjecting capital T in terms of x. Right? From equation 1, what I am doing, look here, equation 1, what I am doing, I am subjecting capital T. Very carefully listen. So go home and once again do it. Capital T equals how much? 30 over x cos 45. Now cos 45 means you know that 1 over root 2. Okay. Now if I simplify this further, 30 equals x cos 45 means 1 over root 2. Cos 45 means 1 over root 2. Time is capital T. Time is capital T. Time is capital T. Time is capital T. So then what you can do, you can write down what? X capital T is how much? X into capital T equals how much? X into capital T equals 30 root 2. I will give a hint. There are different ways of doing this. One can subject T in terms of X and one can do it. Look here, my advice. So there are different ways. One way is, I know xt equals 30 root 2, right? I know xt equals 30 root 2. What you do? Substitute here. Xt means 30 root 2. Minus 1.5 equals xt sine 45. Xt sine 45 minus 5t squared. Xt means you know that 30 root 2. Substitute 30 root 2 here. Then you can find t easily. Then you know t means you know x. Do you understand? Hands up who understand I'm saying hands up? How many of you understand I'm saying hands up? If you understand hands up, now you know now there are different ways. Now we got that x into t means 30 root 2. So substitute here. Then you can find t. If you know the t value, you can find x also. Genuinely hands up who understand I'm saying hands up? If you understand? Okay. Time is 11:12:56. Time to stop the class. Now I advise now if you have friends and if you think that my classes are good, please better you give a small support. Let them know about there is a class like this. Okay. So genuinely hands up. Whatever we learned, if you really understand hands up. Whatever we learned, if you really understand hands up. And do this question, send me. First homework is do this question, send me. This one, send me. Second one is in vertical motion, the last simple B part, that balance scenario, balance story, balance stone story. Try to do it and you are working. It's okay. You get the answer, you don't get the answer, fine, send me. Third one, send the feedback. Send the feedback. Plus, minus, problems you face. Class finished. Class finished. Have fun. We'll meet next day. Bye. What a series. Itu boleh class